This is Teacher Harold, your junior high school mathematics teacher. And in this video, I will discuss the next lesson under quadratic function. And the title of this topic is Transforms the quadratic function, probably particularly from standard to vertex form and vice versa. So, the objectives of this lesson are the following. So, the learners or students are expected to transforms the quadratic function from y is equal to ax squared plus bx plus c form to y equals a quantity x minus h squared plus k. Now, the first equation is known as the standard form, and the second equation is known as the vertex form. Second objective, students are expected to identify the maximum and or the minimum value of the function. For our next slide, in our previous lesson, we learned about quadratic function y equals ax squared plus bx plus c. We represented a quadratic function using table of values for x and y, where we get the equal second differences in y, indicating a second degree function or the quadratic function. Also, we understand that a real-life situation or word problem shows a quadratic function when the relationship between any two pairs of values of x and y has no direct linear relationship. What is the difference between these two forms, the standard and vertex form? This one. Recall that a function is a relationship that exists between two sets of values x and y. The quadratic function is of the form y equals ax squared plus bx plus c, where the coefficients a, b, and c are real numbers and a cannot be equal to 0. Also, y equals ax squared plus bx plus c is the standard form, while the other equation, which is a quadratic function also, and that is y equals a quantity x minus h squared plus k, is called the vertex form of this quadratic function. Actually, this is a function. Since we learned that the values of y increases and also decreases, or vice versa, as x increases, the point of turning of direction is called the vertex, defined by a pair of coordinates h and k, which corresponds to the x and y coordinates or values. Transforming y equals ax squared plus bx plus c to y equals a quantity x minus h squared plus k. The vertex form of quadratic equation or function is defined by the equation y equals a quantity x minus h squared plus k, where h can be expressed as the negative ratio of b to 2a, and k can be expressed as 4ac minus b squared all over 4a. The method of completing the square is used to transform this standard form to this form, the vertex form. Now, a quadratic function, number one, has a minimum value of k if a from here is greater than 0 or the value of a is positive. And sometimes, the quadratic function has a maximum value of k provided that the value of a is less than 0 or a is a negative value. The value of a determines the direction of the opening of the graph of quadratic function, whether the opening is opens upward or opens downward. Next. transform the following quadratic functions in the form y equals a quantity x minus h squared plus k. Then, identify the maximum value or the minimum value. Number 1, suppose we have this quadratic function which is already written in standard form. So, the equation is y equals 3x squared minus 12x plus 5. So, for our solution, now this standard form is now about to be transformed or written in this form. We call it the vertex form. So first is we factor out the common monomial factor from these first two terms. And in this particular case, the common factor of 3 and 12 is 3. Then there is another factor that is common to these two terms, and that factor is x, no? Or better yet, 3 lang yan, no? Now, inside the parentheses, the expression or the resulting expression would be x squared minus 4x. So, how did we get this expression? So, ganito yan. Now, since we factor out 3, we need to write the term that is left when the factor 3 is factored out. So, that is 3x squared divided by 3. That will give us x squared minus, copying that sign, 12x divided by 3. That is 4x. Now, why did I provide an additional space before I close this using the close parentheses? Because we are trying to make this expression inside the parentheses a perfect square trinomial. So we need to add the third term to make this expression inside the parentheses a perfect square trinomial. So in this case, the missing third term is what? Will be taken from the coefficient of this term, and that is 4. We take half of that. So multiplied by 1/2, we know that the result is 2 at that point, and the result 2 is to be squared, and we have 4. And this one right here is actually the missing third term to be placed here. Yun. So it's plus 4. Now, for this equation to be restored to its original form, whatever we did inside the parentheses, we need to counteract. So in this case, what number did we put? 4. Now, para makontra natin at mabalanse natin ito na ito pa rin ang magiging original equation, we need to subtract the resulting equation by 12. Now, why is it 12 and not 4? Okay, because this entire expression inside the parentheses is actually being multiplied by 3, including 4 inside. Therefore, what we actually add is not plus 4, but plus 12. And 12 is actually the result when this 4 right here is to be multiplied by 3. So, since we add this equation at this moment by 12, we need to counteract that we did. We need to counteract the what we did. So, we add 12, we subtract this equation by 12. Yun. And the result of the equation is this one. So since this expression is now a perfect square trinomial, this is now can be expressed as the square of the binomial. Ayun. Then square. Okay. Ito na yun, no? The factored form. Then 5 minus 12 will give us what? Minus 7. And at this point, this is now the new form of this original equation, and this is what we call the standard form, or the vertex form rather. The original given equation is actually the one written in standard form, and this is what we aim for, the vertex form. Yeah. Then what is the next step? Determine whether the function has a maximum or minimum value. Ayun. Now, A here is 3, which is positive. So, ano ibig sabihin yan? If the value of A is positive or greater than 0, of course, H, which is 2, is taken from this one. Then, K is what? Yun. Negative 7, which is taken from this one. So, the vertex is at what coordinates? 2 and negative 7. K is negative 7. Since A is equal to 3, which is greater than 0, then there is a minimum value of Y equals 7, which is actually taken from the value of K. Yun. Okay, next. Number 2. How about this equation? Y minus 4 equals negative quantity to x squared minus 12x. So, just like in number 1, we are going to rewrite this to vertex form. Solution. Transforming this equation first to standard form. So, what will happen to this equation? So, this is what will happen to the equation. Okay? Removing the open and closed parentheses, meaning those terms inside the parentheses, each one of them, we change their sign. Okay? So, sign, negative 2x squared. Then, from negative, it becomes positive 12x. And then, negative 4 transposed to the right. At this point, the given equation is now in standard form. That is y equals negative 2x squared plus 12x plus 4. Now, why did we declare the values of A, B, and C? Negative 2 for A, 12 for B, 4 for C. Because we are going to use two formulas to compute for the values of H and K. Yun. So, the formula to compute for the value of H, that is H equals negative B over 2A. And for K, this is the formula for AC minus B squared all over 4A. And we substitute the values of A, B, and C to these two equations. First, we go to the computation of H for the value of H. So, that is negative B, which is 12, all over 2 times A, which is negative 2. If we are going to simplify this expression right here, the value that we get for H is 3. Okay? Now, for K, we substitute the value of A, C, and B, and this is the resulting expression. So, applying the GEMDAS rule to simplify this expression, the value of K is what? The value of K is 22. Therefore, the vertex form, or so therefore the vertex is at coordinates 3 and 22, which are the values of H and K respectively. Now, since the value of A is negative 2, or that is less than 0, then this given function has a maximum value of Y, which is 22. Yeah. 22 is a value taken from what? K. And K is part of this so-called vertex form. Okay? So if there is no question, we now continue. We proceed to the slide presentation. Okay. So substituting the values of A, H, and K in this form, therefore, the resulting quadratic equation in vertex form would be what? Y equals A, which is negative 2, times quantity x minus 3 squared plus 22. And this is now the vertex form of this original quadratic function. Next, about number 3. Okay, number 3, not written, neither written in standard form nor vertex form. But still, just like the previous two examples, we need to transform this to vertex form. Okay, for our solution, okay, y from right transpose to the left, so it becomes negative y. How about 6x squared? We transpose this to the right. And we place it after the equal sign, followed by 24x plus 8. And at this moment, this is not yet totally the vertex form because we need to eliminate the negative sign from this side. So, from negative y, it should be y. So, multiply both sides by negative 1 in order for this y right here, from negative, it will become positive. So, basically, all terms, the sign of each terms must be replaced. So if originally the term is negative, you make it positive. Or if it is originally positive, you make the term negative. And this is what happened to the equation. At this moment, the given equation is now written in standard form. And to make this equation transform to vertex form, what do we do? Okay, we use the two formulas to compute for the value of h and k. So we must declare the values of a, b, and c. And these are 6, negative 24, and negative 8. So, using the two formulas, okay, I have mentioned this from the previous example. Now, to compute for h, okay, substitute the value of b and a. Okay, then simplifying this result, h is 2. Now, for k, of course, substitute the value of a, c, and b. And then simplify the resulting expression on this side. Okay. So now, this is the resulting expression. In order to simplify this, again, we follow the PEMDAS rule or the GEMDAS rule. And the result is that k is what? Negative 32. With that, we can declare the vertex of this quadratic function in terms of x and y coordinates. And the vertex is what? At coordinates 2 and negative 2. This is for h and this is for k. Now, since a is equal to 6, which is greater than 0, then there is a minimum value of y which is equal to negative 32. Okay? Now, for number, okay, substituting the values of a, h, and k, we can now determine the specific vertex form of this given quadratic function. And that is, yun, 6 quantity x minus h, which is 2 squared, plus negative 32. We're not done yet. So positive, negative, it's just like multiplying a number after the open parenthesis, and we know that number is 1. So it's positive 1 times negative 32. The result is what? Negative 32 or minus 32. So that the vertex form would be what? Y equals 6 quantity x minus 2 squared minus 32. And again, this is the vertex form. Okay? Next, just like those three previous examples, equations in 4 and 5 must also be written in vertex form. Okay, so you just do the transposition. Y from the right side should be placed on the left, and all these terms must be transposed to the right side. But if we're going to write this term, this expression, we must write first the quadratic term, followed by this linear term, and the last term should be the constant. Okay? Ayun, ito na yun, no? Okay. Every term from one side transposed to the right will change its sign. Ayun. Okay. Then, why did we declare for A, B, and C values upon transforming this equation to standard form? Okay. We are going to compute for the values of H and K, so we are going to use the formula, the formula of those two, and these are the formulas. Okay, substituting the values of A, B, and C to these two formula in order to get and compute for the values of H and K. Okay, so for H, substitute A and B values and simplify, so H is equal to 2. How about K? Okay, using this formula, we substitute the given values. And this is now the resulting expression. So if we're going to simplify this, again recall about the PEMDAS or the GEMDAS rule. And at this point, the value of K is negative 15. So what does this mean? Therefore, we can declare the vertex, which is in terms of a pair of coordinates H and K. And particularly, the vertex of this given function in number 4 is a pair of coordinates 2 and negative 15. And since A is 2, which is greater than 0, then the function in number 4 has a minimum value of y, and that is taken from K, which is negative 15. Okay? And then for number 5, so for the vertex form, we use this and substitute the value of A, H, and K. And this is the vertex form. Now for number 5, okay, number 5 is almost written in vertex form. So what we're going to do, we simply place this to the right side. Okay? Before 9. So ano mangyayari? Ayun, naging vertex form na agad. Okay? This one. We simply transpose this to the right before 9. Ayun. And after the equal sign. Ayun. Ito na yun. Then from that vertex form, A is negative 4, H is 3, and K is 9. So the vertex is at coordinates what? H and K, and these are 3 and 9 respectively. And since A is negative 4 or A is less than 0, then there is a maximum value of y, which is equal to 9. And again, this value is taken from K. Ayun, this one. And with that, I think I'm done discussing the topic, and at this point, we have the assignment. So basically, you just answer the following items. Number 1, number 3, number 5, number 7, and 9. Okay, so that would be all. And see you next time.